right, hi guys, this is Mrs. Levenseller here. We just want to introduce some polynomials today, and this is not really necessarily anything new. It's things that you've been working with before, but we're going to take it a little bit further now. So we're going to look back at multiplying them, which is something you've seen, and we're going to start talking about factoring, which is one way to divide your polynomials apart. So I've created this note sheet so you can fill this in with me as we go, so make sure you have one of these before we get started. And we're going to start with the definition of a polynomial, okay? So a polynomial is an algebraic expression. So algebraic expression, which just means we have variables, we have numbers. We're going to deal with not equations at this point, but just expressions. So there won't be any equal signs until we start to graph these. And you guys already learned how to graph the quadratics. And this algebraic expression is made up of one or more terms. So if you recall, a term is just a number multiplied by a variable, or it could just be a number, or it could just be a variable. But we can have one of those terms, or we can have multiple. We can classify polynomials by their names. So here we have the three most common names, and then polynomial is a more general term. The first one we see is a monomial. So the prefix mono, that represents the number 1. So a monomial is a polynomial with one term. So an example of that might be the number 3. That's one term, that's a polynomial. Or maybe we have an x, that's one term, so that's a monomial. Or maybe we have 5x squared, also a monomial. So all three of those things would be examples of monomials. Next we come to a binomial. Well, the prefix bi is representative of the number 2, so that means we have two terms. So that would be anything that has to have two terms that are not like terms. They can't actually be added together. So x plus 3, that expression, is a binomial. I'm putting parentheses around it just to show that that's a group. You might have 3y minus 7. Those aren't like terms. That's as far as they could be combined, so that would also be a a binomial. Has two terms. A trinomial, as you might be able to guess, has the prefix tri means 3, so that has 3 terms. And that might look like the quadratics you've just been graphing. X squared plus 7x minus 1. All three of those pieces have to be separate, and since there's 3 of them, separated by addition and subtraction, that makes it a trinomial. A polynomial, the prefix poly just means many. So this polynomial, it just represents an expression with 4 or more terms usually. We can also refer to any of these binomials, trinomials, or monomials if we want to be less specific about it. They are all in the family of polynomials. But if you see like 6x to the third minus 7x squared plus 4x minus 8, because there are 1, 2, 3, 4 terms, that's why we're calling it a polynomial instead of more specifically a monomial, a binomial, or a trinomial. So in part of your assignment, you're going to be asked to classify the different types of polynomials, and those are the 4 terms you're going to use to classify: monomial, binomial, trinomial, or polynomial. The other piece of the directions that you're going to be asked to do is to write your answers in standard form. So a polynomial is said to be in standard form when the terms are written in descending order. So descending order here. All right. Descending order means that your terms are going to go from the highest power down to the lowest power. And the lowest power is usually going to be the number that's a constant. So this one that we did up here to represent the polynomial, that one's written in standard form because we start with x cubed and then we go down to an x squared and then an x and then a constant. So that one is written in standard form. If you recall, we have added and subtracted polynomials before. In order to do that, like this example that we have down below, you're really just combining like terms. So we need to be able to combine like terms. And so by adding and subtracting these polynomials, we can create a new polynomial by adding what is a like term. So let's take a look at this example here. And the first thing I'm going to come to is 2x to the third. So I'm going to look across my problem and say, okay, are there any other x to the thirds? Because remember, a like term has to have the same variable with the same exponent. Well, there are no other x to the thirds, so that means that piece of my polynomial has to stay by itself. So the beginning of my equation, because this is the highest power, I want to write it in standard form. I start with that one. It's going to be 2x to the third because there's no other match. I'm going to cross it out once I'm done using it and move on to the next set, the next highest power. Here I have a negative 3x squared, and oh, I see another x squared in the second polynomial. Well, negative 3 plus 5 would give me 2x squared. Remember, the power doesn't change when you're adding and subtracting. The next highest power I see is, I'm going to skip the 4 because that's just a constant. I see a 3x over here, but there are no other just single x's in my two polynomials. So that term is just going to get brought down by itself, so plus 3x. All right, now I've used those two. I've used 3x. And lastly, I see 4 as a constant and negative 1 as a constant. So I'm going to add those together because this tells me to add. So 4 plus negative 1 would give me positive 3. So this here is my new polynomial that I got from adding those two polynomials together. So you're just combining like terms, and remember, like terms have to be the same variable raised to the same power. All right, and so the last piece here is just looking at the distributive property. So we're going to multiply our exponents, our polynomials. And remember, when we multiply powers, we're actually adding those exponents, okay? So when you multiply a monomial times a monomial, you have to add the exponents on the variable that is the same. So we'll start here with just this first one. So a monomial times a monomial is what we have right here. 3x to the fourth times 5x to the seventh. Well, I'm going to start by taking the two numbers and multiplying those together. So 3 times 5, which would give me 15. And then I'm going to take the x's, and multiply those together. So x to the fourth times x to the seventh. So remember, when we're multiplying variables, we add our powers. So that would give me x to the 11th. So this would be 15 x to the 11th. With the second example, we are going to multiply a monomial by a polynomial. So I chose a monomial by a trinomial, but this same process works no matter how big that second polynomial is. Could be a binomial, could be 7 terms long. You're still going to use the distributive property to simplify. And when we distribute, it's going to be essentially a bunch of little problems like the very first one. So let's walk through and see what that looks like. So I'm going to start with negative 2x squared getting multiplied by 4x to the third. So I'm going to do negative 2 times 4, which would be negative 8. And then x squared times x to the third, I'm adding my exponents, so I get x to the fifth. Then I go to the next term, negative 2 times Let's get some different colors here. Go to my next term. So negative 2 times negative 6 would make that positive 12. And x to the second times just an x. Remember, there's a little imaginary power of 1 if you don't see it. So that would make that x to the third. And then finally, negative 2x to the second times 1 is just negative 2x to the second. Remember, you can multiply anything, but you can only add and subtract like terms. So I'm allowed to multiply negative 2x squared with 1, even though 1 doesn't have a variable. And so here's my final answer. I would want to look at that and see if I could combine anything, but they all have different powers, so that's as far as I could go. So go ahead and try the beginning of your first assignment, and then when you're ready, watch the second video on factoring with the greatest common factor.